On this particular video, we're going to be looking at trigonometric equations. We've already covered the basic principle underlying trigonometric equations. And we've talked about the basic idea which you need to use, or the basic principles which you will need to use in order to solve these equations. However, for this lesson, I will just be focusing on how to use those principles and applying some of the core functions that we've learned, and also doing equations that require factorizations. Factorizations of highest common factor, difference of squares, as well as trinomial. We will also look at equations using square identities and equations using negative angles, as well as reduction formulas. And then from there we'll move to more of grade 12 stuff, where we use compound angles as well as double angles. Now all of this stuff will be based on the same principles that we've talked about on an introductory video. Whenever you're solving trigonometric equation and sign is involved, let's say sine theta equals a. We've talked about the fact that a here is a number that should be between and equals to negative 1 and 1. Now you have to apply second function of sine in both sides of the equation. Therefore sine second function multiplied by sine theta is equals to sine second function of a. Now this and this will cancel. Therefore theta is going to equal sine second function of a. A is a number between negative 1 and 1, and also can equals negative 1 as well as 1. Now this is our reference angle. I'm going to go through this one quick because we've already covered some of the stuff relating to this. And in that case, I'm going to have theta for more general solution is going to be my reference angle plus 360 degrees times k, where k is an element of integers. 360 the period of the function of sine theta. Now next up will be taking that reference angle and subtracting it from the reference at the 180 degrees. And if we take that, we still have to add 360 degrees times k, where k is an element of integers. Always write that every time you make that statement. So this is the general solution that you use when you're solving your trigonometric identity equation, rather, using theta, using sine theta, or the sine ratio. If the cosine ratio is involved, a is still between negative 1 and 1. You're going to have theta equals cosine second function of a. This is more like when you punch a shift and then cosine on the calculator. Now when you do that, something like that will pop out, and then you just put that in the brackets. That number will be within that domain. Now when you get this, that will be a reference angle. Therefore theta is going to equals plus or minus that reference angle plus 360 times k. Again, k is an element of z. Now be sure to check the video where we did the introductory part to this, and it will make more sense, because there I've talked about what each of these individual components are. However, here I'm not going to elaborate a lot. I'm just going to go through them quickly as a form of a reminder or a little bit of a revision to what we've done. Now that will be a general solution. Now for tangent, theta equals a. Here the a can be the element of real numbers, or is an element of real numbers. Now any real numbers will work for a, as long as tangent is involved. So for the ratio tangent, we don't have to limit our a between negative 1 and 1. In this case, theta is going to be tangent second function, or second function tangent a. Again, this will be the reference angle. Now what I need to do with the reference angle is simply to add 180 times k, where k is an element of z. The 180 here is the period of the graph of tangent. Now let's go ahead and take some examples to those problems. Let's say they want you to solve for theta, and you're given sine theta equals sine 2 theta rather equals cosine theta. Now how can you resolve that? You can go ahead and pause the video and just try to go through this information, and then unpause the video, and then we'll walk through the problem together. What you need to do here is to make sure that on both sides of this equation you have the same ratio. Here I have a ratio sine, here I have the ratio cosine. Now I need to change this because here's a double angle, so I won't be able to change that. Now what I want to do is not to expand that double angle to that. I can do that, but that's not the whole point. What I want to do is to be able to change this one. All right. So what I'm going to do is I'm going to write 2 theta, or sine 2 theta, is going to equals, remember using the co-ratio, this is more of when I have sine 90 degrees. I want to use the same ratio. If I have sine 90 degrees minus theta, I know this is a co-ratio for cosine theta. Simple as that. So I'm going to remove the cosine theta and put the sine 90 degrees minus theta. And then in that case I'm fine. Just going to go ahead and get rid of that. So on both sides of the equation I have the sine theta. This is sine 2 theta and that is sine 90 minus theta. So what I need to do in that case is basically to remove the signs and be left with 2 theta, the ratio. And here's going to be 90 minus theta. The 90 minus theta here is going to be my reference angle. All I need to do for a general solution is to add 360 times k, where k is an element of integers. The second solution to that will be 2 theta equals, remember, I need to take 180 degrees and minus my reference angle. My reference angle is the 90 minus theta. Just make sure that you maintain those parentheses there to avoid making mistakes. Now, there we go. The next thing that I'm going to do is to basically resolve that part. So you can see I have 90 minus theta and I have 2 theta. I need to solve for theta, and theta is on both sides of the equation. What I'm going to do is to add theta on the right as well as theta on the left. The negative theta, positive theta will equals to 0 theta. So on the right hand side I've gotten rid of the theta, but on the left hand side I have 3 theta equals 90 degrees plus 260 times k. Now I don't have to keep writing k element of z at this point. So the second solution to that is going to be, what I need to do here is to subtract the 180, to subtract 90 minus theta from the 180. So 180 minus 90 is going to give me 90. So 2 theta is going to give me 90. And then here, pay attention, you have a negative times a negative, which is going to be a positive theta. So I'm just going to write it there, plus 360 times k. Now I'm going to go back and just resolve that. This is 3 theta. I'm not looking for 3 times theta. I'm looking actually for theta. So what I'm going to do is I'm going to simply divide by 3. And also divide it by 3 and also divide it by 3. 260 times k, these are simply a product. So if I divide by 3, I've divided by 3 for the whole 360 times k. Now the 3 and 3 will cancel here. I will remain with theta. All I need to do is to find what is 90 degrees divided by 3. So it's going to be 90 divided by 3, which is going to be 30 degrees. So that's going to be 30 degrees plus, again I have 360 divided by 3. That's going to be 120. So that's going to be plus 120 degrees times k, where k is an element of z. So this will be my general solution. But what about this one? Now for this one I need to just basically subtract theta both sides first. That theta and theta will cancel. Here on the left I'm going to have theta. So theta for that one is going to be simply 90 degrees plus 360 times k. And then I'm done. Let's go ahead and take an equation that requires more factorization. This will be the type of problem that you can basically expect from an exam. Now, it may involve a simple quadratic, or it may involve quadratics that basically will have compound fast, and then you will have to work the compound, and then so on and so forth, or maybe the square identities, and so on. But whichever way they give it to you, you will have to work it the same way. Let's say they've given you 2 cosine squared theta and plus cosine theta minus 1, and then it's equals to 0. Now, the first thing you need to do is to identify what that is. The 2 cosine squared theta plus cos theta minus 1. If you can factorize algebraic equations, it's easy to factorize trigonometric equations, because what we do essentially is the same. It just looks different when you're dealing with the ratios. But let's say we had 2x squared plus x minus 1 equals 0. I'm sure you would be able to factorize that. Right? But essentially, that's the same thing as that. All right. The fact that we have cosine here and cosine squared there shouldn't derive or shouldn't move you from the whole idea, or deter you from this whole point of what exactly is it that you need to do. You need to factorize. This is a trinomial. We have the quadratic here, we have the constant, and we have the linear here, the constant there, rather. So what I'm going to do is to just simply factorize that thing. The factors of 2 are 2 and 2, and then x is going to be x and x for x squared. And then the factors of 1 are simply 1 and 1. What I need to do is to find the factor which is positive. My middle term here is positive, meaning that the bigger factor is going to be positive. Right. So if my middle factor, my middle term is going to be positive, then 2 times 1 should be the one which is positive. If I subtract 1 from it, I'm going to get 1. In that case, 1x. So all I need to do is just to replace, at the places of x, is just to simply place my cosine ratio. As simple as that. So whenever you find it difficult to factorize that, just use your algebra. Replace the ratios with the sines and cosines, or tangent with the x and y's and z's. It's easy to factorize that, and because you've learned how to factorize with those for the longest of time, you will be able to factorize these ones as well. But it's going to take a little bit of time, and it requires practice for you to see them or to identify them. So I'm going to have 2 cos x and then cosine x, and then I'm going to have 1 and 1. Remember here I said it's a minus and there's a plus. So I have 2 factors. Each individual factor here will be equated to 0. So 2 cosine x minus 1 should equal to 0, or cosine x plus 1 equals 0. All I need to do is to solve for cosine x. So 2 cosine x equals positive 1. I'm going to add 1 both sides of the equation, and then divide it by 2, and then cosine x equals 1/2. Here is just simply going to be cosine x equals negative 1. Now both half and negative 1 are within the domain of negative 1 and 1 for a. And so I will find my general solution for both. Let me just first work with that one. This will be x is equals to second function cosine 1/2. If I have second function cosine 1/2, all I need to do is to simply take a calculator and then just punch that. Remember, it's a shift, and then you put a cosine, and then you put 1/2. That's going to be 60 degrees. So that's going to be 60 degrees. All I need to do to the reference angle, which is the 60 degrees, is to put plus or minus before it. And then that's going to be plus 360 times k, where k is an element of z. Now, I'll be done for that one. But what about that one? If I'm going to do that one, I'm going to do the same thing. So x is going to be Second function cosine -1. And again, for that, I will pull up a calculator. So it's shift cosine of a -1. It's 180 degrees. So I'm going to have x as plus or minus 180 degrees, plus again 360 degrees times k, where k is an element of z. So I'm done for that. Right. So you see you have two separate solutions. You can simply work with those separate solutions just like that. Now let's take another one which also will require factorization, but a different type of factorization. What would you do if they wanted you to solve for x? If they're given you 2 sine squared x minus sine x cos x, and then minus 6 sine x, and that's equated to -3 cosine x. Now, the first thing we need to do is to take this term to the other side. That's all we need to do. So I'm going to have 2 sine squared x minus sine x cosine x, and then minus 6 sine x. And then I'm going to have to add 3 cosine x both sides. That's going to be 3 cosine x. And then when I add 3 cosine x on the right, the result will be 0. So I have a 0 right there. Now looking at this, I have 2 sine squared x and sine x cos x, and then I have 6 sine x and then 3. It looks like the 3 and the 6 here, I will be able to take out the common factor of a number. Alright, because these terms are different, but they have the common factor of 3. But here, I feel more like I need to take the common factor of sine, because here I have a sine and on the next term I have a sine. So I would have to group these terms. So this is the factorization that involves grouping first. So what I'm going to do is just basically to rewrite this whole equation and then show you how I'm going to group that. So the 2 sine x or sine squared x minus sine x cos x would be a group. So I need to put them within the same parentheses. I have a minus here. So when I open a group, I make sure that every sign inside the bracket will change. So I had a negative here, -6 sine x. So I'm going to have a positive 6 sine x. And then here I had a positive. I'm going to change the sign to a -3 cosine x equals 0. Now just make sure that whenever you put out the bracket and then you have a negative sign, every sign inside the bracket will change. For example, I had a -6 sine x, and then inside the bracket the 6 sine x is a positive. And I had a positive 3 cosine x. And inside the bracket, this is going to be a positive, a negative rather. So that when I multiply inside the bracket, this is going to be negative and that's going to be positive. And nothing is essentially changed. So now I have a group. In this group, I will take out the common factor between the two terms. That's the sine x. If I take out sine x, here the remainder will be 2 sine x. And then here I will be remaining with simply cosine x. And then a minus. Here I'm going to take out the common factor of 3. That's the lowest common factor. And then here the highest common factor rather. And then here I'm going to be left with 3, rather 2, because 6 divided by 3 is a 2. 2 sine x. And then here I'm going to be left with cosine x equals 0. So you can see here I have these terms on both terms. I have these 2 sine x cos x and then 2 sine x minus cos x. So that will be my common factor between these two terms. Because remember, terms are separated by a plus or minus. I have only one minus here. And this is just one term, and that is also just one term. So what I need to do is to take out the common factor of 2 sine x minus cos x. And the remainder here will be sine x. And then the remainder here will be a -3 or -3 equals 0. So I have two factors. Each individual factor I can equate to 0. Therefore 2 sine x minus cos x equals 0. And then sine x minus 3 will equal 0. All I need to do is to solve for sine x. Therefore 2 sine x for this one is going to equal, so I'm going to add cosine x both sides of the equation, plus cosine x here, plus cosine x there. That and that will cancel. I'm going to have a 0 plus cosine x. So the cosine x moves to the right, which is positive cosine x. At that point, remember, when we're dealing with sine x and cosine x, we need to divide by cosine x. The sine x over cosine x is a tangent x. So I have 2 times tangent x equals that and that divides into 1. At that point, I'm just going to divide by 2. So simply what I have here is tangent x is equals to 1 over 2. However, the 1 here is not that difficult to work with. So I'm going to have sine x equals, so I'm going to add plus 3 both sides of the equation. That and that cancels, or gives me 0. On the right hand, I have 3. Now remember, when sine and cosine are involved, the a should be a number between negative 1 and 1, and also equals to negative 1 and 1. However, that number is a 3. Doesn't fall within the interval. So there will be no solution for that one. So you just leave it like that, or you just crash it. Sine x is not going to equal 3. Alright, so I'm just going to have to work with this one only. So the tangent x equals 1 over 2. So x is equals to tangent, or second function tangent half. Put out a calculator for that, and then you have shift tangent 1 over 2. If you have shift tangent 1 over 2, that's going to give you 26.56 degree. So I'm just going to go ahead and write x equals 26.56 degrees. Now, the 26.56 degrees will be the reference angle. All I need to do is to add 180 times k to the reference angle, where k is an element of integer. You can make this, by the way, is 26.565. That will be 26.57 if we round to 2 decimals. Don't forget to write k element of integers, and then you're done. So in a nutshell, that's what you need to do. You're applying yourself slowly but surely, and you will get where you need to go. Now next, I'm going to take a look at the one that involves using square identity. Remember, our squares identity are sine squared x plus cosine squared x equals 1. And if you can solve for either sine squared x or cosine squared x, we have sine squared x equals 1 minus cosine squared x. And cosine squared x therefore would equals 1 minus sine squared x. These are our square identities. Simple as that. This is all you need to remember. If you can remember this, then you're doing trigonometric identities, or simply equations rather, as well as trigonometric identities. Involving square identity will be easy for you to do. Just these ones are enough. Let's take a look at the problem that will involve us using square identities and solving for trigonometric equations. What would you do if they wanted you to determine the general solution for 3 cosine squared theta minus 5 sine theta and then minus 1 equals 0? You can see that here is simply a factorization of a trinomial. But the problem here, if I was using my 3x squared minus, that would be 5y minus 1. So I have a problem with the y and the x because they are not the same. All I need to do is to be able to change, because I can't change the y here in the middle, I just need to change the x. So the cosine squared theta, I need to change it. But this one I won't be able to change. It's a middle term and it's linear. There's nothing I can do. However, I can be able to change this into 1 minus sine squared theta. So therefore my quadratic, the sine squared will be the same as my linear, which is the sine theta. And then I will have my constant minus 1. Simple as that. So what I'm going to do is take a 3, and then instead of having cosine there, I'm going to have 1 minus sine squared theta. And then I'm going to close those brackets. And then minus 5 sine theta minus 1 equals 0. All I need to do is to multiply the 3 inside the brackets, or distribute the 3. Now if I do that, this is going to be 3 minus 3 sine square theta minus 5 sine theta minus 1 equals 0. Now that I'm here, I can be able to find my constant terms and just simply add them together. So the constant terms is a 3 minus 1, which is going to be a 2. So I'm going to start with negative 3 sine square theta, and then minus 5 sine theta, and then the 3 here minus 1 give me a positive 2 equals 0. The coefficient of my quadratic, however, is negative 3. Now I won't be able to take out the common factor of negative 3 because here is a 5 and here is a 2. So the negative 3 is no common factor. However, I will be able to take out the common factor of negative. So I factor out the negative, and when you do that, it simply changes every sign inside the brackets when we've taken out the common factor of a negative. So this one is going to be plus 5 sine theta, and that one lastly is going to be minus 2. And then I'm going to equate to 2. I'm going to divide by a negative 1. So I have 3 sine x. 0 divided by that is just basically simply going to be 0. Minus 2 equals 0. So I need to factorize that. Now I need the factors of 3. 3 is a prime. So it's going to be 3 and 1. So I'm going to have 3 sine theta and times sine theta. Again, 2 is also a prime. I'm going to have 2 and 1. But I'm going to have to be specific in which I place the 2 and 1. So all you need to do here is to figure out that in order to get 5, you need to take 3 and multiply by 2 to get a 6 and subtract the 1. Because this sign tells you that you must find the difference. And the difference of 5. In which the bigger number or the bigger factor takes the positive. So I need to put 2 here. So remember, the outer term and the inner term are the ones that give you the middle term. I'm going to put 1 here. So the plus is going to come here because the bigger term should be the plus. And then here's going to be a minus. So I'm done. I'm going to have 3 sine theta equals 1, or sine theta equals negative 2. I've already equated each factor to 0, and I've already solved for sine theta. Here I'm just going to simply divide by 3, and then that will give us a 1, and then sine theta times 1 will be sine theta equals 1/3. However, for this one, we have a red light again. You see it's a negative 2. And remember, when sine and cosine are involved, the a, or that number right here, should be between negative 1 and 1, and also equals to negative 1 and 1. So this one won't be part of the solution. So I'm just going to go ahead and simply write no solution for that one. I'm just going to have to work with this one. 1/3 is a number that's between negative 1 and 1. So theta is going to be second function sine 1/3. And all I need to do is just basically to take out a calculator for that. So I'm going to have second function, which is a shift, and then sine 1/3. Now that's going to give me 19.47. So that number right there is a 19.47. So I'm just going to quickly write 19.47. The number that comes after a 7 is a 1. So the 7 will stay the same. So theta is going to be 19.47 degrees plus 260, which is the period of this function, times k element of the integer. And that's all you need to do. Remember, we're not given a restrictive domain. We're just going to work with it the way we are working, simply giving only the general solution. Now, we'll come across problems that will have limited domain, but right at the moment, we're not dealing with those. Let's take another example. How can you find the general solution of 2 sine squared theta minus cosine theta plus 1? Now, this one looks like the one that we've just done. Now, all you need to do is to just figure out that my middle term here is a cosine, and my quadratic here is a sine. So you need to change that quadratic into 1 minus cosine squared theta. If you do that, then you have your first term, just like we did with the previous one. Your quadratic has cosine, and then your linear will be cosine n plus the constant 1. And therefore you will be able to factorize the trinomial. So this is going to be 2 times, that's going to be 1 minus cosine squared theta. Remember, we're using squared identities here. And then minus cosine theta, not x, plus 1. We're going to equate that to 0. And then again, we do the same thing. We factor the 2 inside. This is going to be 2 minus 2 cosine squared theta minus cos theta plus 1. And that will all equals to 0. Now again, I have a 2 minus 1, which is going to give me a 2. So I have a negative 2 cosine squared theta minus cosine theta. And then the 2 minus 1 is going to be, a 2 plus 1 rather, is going to be a positive 3. We almost made a mistake right there. Alright? Was distracted by this negative. Alright, all I'm going to do is to just, I won't take out the common factor of negative 2, because I have 1 here and there I have a 3. So the negative 2 is not a factor, but the negative is a factor. So if I do take out the negative, I'm fine. So this is going to be 2 cosine squared theta plus cosine theta. Remember, taking out the negative as a highest factor or common factor, you just need to make sure that anything inside the brackets changes its sign. This was a negative and is now a positive. This was a negative, is now a positive, and this was a positive, is now a negative. That's all you need to do. So what I'm going to do at this point is to divide by negative 1. Divide by negative 1. And then I now simply have 2 cosine theta plus cosine theta, and then minus 3 equals 0. The factors will be more or like similar to the previous one that we've done. Now the factors of 2 basically is 2 and 1. It's a prime number. So it's going to be 2 cos theta, and then I'm going to place cosine theta here. Now again, the factors of this one are also a prime, but the difference here is going to be a 1. So I need to put the 3 here and the 1 there. And then the 3 and the 1 are placed in that particular order because I want to take the 2 and subtract it from the 3. So the 2 will be a minus, that factor that involves a 2, and this one will be a plus because my middle term is a plus. So I'm going to have 2 cosine theta equals negative 3, or cosine theta equals 1. At this point, I'm just going to have to divide the 1 on the left by 2. And that will cancel. And then you have your cosine theta equals negative 3 over 2. Or here, basically, it's equals to 1. 1 is between negative 1 and 1, as well as equals to 1. So 1 is equals to 1. So it's within the range, domain rather, in the range, or the interval that they want us to have a in. So if you punch that cosine second function 1 equals theta, you won't get a negative. You won't get an undefined number rather, or a math error. You will get a solution. And you will get a solution for this one as well. So let's just go ahead and do that. Let's say we have shift cosine negative 3 over 2. What would that give us? So that's going to be cosine minus 3 over 2, or minus 3.5. That's going to be 180 minus 55 degrees. Weather comes out strange on a calculator. Alright, the reason is because this one, I don't think we'll have a solution for it. Let me check the 3 over 2, if it lies between negative 1 and 1. So 3 over 2 is going to be 1.5. It doesn't lie there. So this one won't be a solution. I was almost blinded by that one. That's why we get a rather strange number there. So this one won't have a solution. So I'm just going to go ahead and say no solution for this one. But however, we do have a solution for that one, which is 1. So I'm just going to have cosine. I'm going to have shift and then cosine 1. It is a positive 1, which is a 0. So the theta here is going to equals 0 degrees plus 360 times k. Times k, where k is an element of z. So we're done. Be sure to make sure that that number lies between negative 1 and 1 so that you do not make mistakes. Let's take one last one. How would you determine the general solution for 6 sine squared theta minus 7 sine theta cosine theta minus 2 equals 0? So this one, we have a little bit of a hassle, but I want you to pay attention to what we're going to do here. Here we have sine squared theta, and we have the b term here, the middle term. So whenever you have a trinomial, you have a form of ax squared plus bx plus c. The constant here is a negative 2, and the middle term here is a sine x cosine x. And then the quadratic here involves only sine squared x. So if we're going to factorize and we identify something like that as a middle term, we need to be able to have the quadratic for both the sine as well as the cosine. So I have the quadratic for the sine only, so I need to get the quadratic for the cosine. So all I'm going to do is to target one of these, because this is more of 1 plus 1. So remember, cosine squared theta plus sine squared theta equals 1. So I'm going to angle on something like this to make sure that one of these is equals to this. And then all I'm going to do is basically to remain with 1 as a constant instead of 2. So let me say 6 sine squared theta minus 7 sine theta cosine theta. And then instead of saying minus 2, I'm going to say minus this, which is cosine squared theta plus sine squared theta. And then I'm going to say minus 1 equals 0, because I have a minus 2. This is minus 1, and this is also a minus 1, which is a minus 2. So I've broken the 2 into minus 1 and 1, of which 1 of minus 1 was this. Excuse me. So all I need to do is just basically to find the like terms here. So I'm going to make sure that I rewrite everything the same, and then I figure out in the negative is the negative cosine squared theta and the negative sine squared theta, and then minus 1 equals 0. This already has a like term here. So that's going to be a 6. That's going to be a 6 minus one of those. So if it's a 6 minus one of those, then I'm done. However, I think we'd rather work the long way doing it like this, but we're still going to get to that. So it's going to be the 6 minus one of those, which is going to be 5 sine squared theta minus 7 sine theta cos theta minus cos squared theta minus 1. Again, the 1 is going to give me a problem here, because I think I need to work with the perfect trinomial, where I have a squared plus ab plus ab squared. So this is a perfect trinomial. I have the problem with the 1 there. However, I could have done it quicker, just instead of breaking 1 by 1 and just basically multiply that by 2. So I just figured out right now that I'm working with a perfect trinomial. So I'm going to make sure that I change it again, the 1. So this is going to be 5 sine. However, I took a rather long direction, but it's fine. I'm going to subtract again cosine squared theta minus sine squared theta, or plus sine squared theta. This is all going to equal 0. So now I have this minus 1 of those is going to be 4 sine squared theta. I'm just trying to take shortcuts. And the middle term obviously is this one. Will be 7 sine theta cosine theta. And then negative sine theta, negative cosine theta, sine, and a negative cosine theta. If I have to add this together, I get a negative 2 cosine squared theta. Now, I think we're fine now because we have the perfect trinomial equals 0. Now, had I noticed earlier what I was supposed to do, I should have, let's say there, because I had the 6 sine squared theta, just take a break from that problem a second, and minus sine 7 sine theta cosine theta, and I had minus 2. I could have taken these two and multiplied by cosine squared theta and plus sine squared theta, because that's going to give me a 1. And then equate that to 0. That would have cut the long story short for me. But I didn't realize earlier on that I was working with a perfect trinomial. So this was going to be 6 sine squared theta minus 7 sine theta cosine theta minus 2 times cosine theta, that will be 2 cosine square theta, and negative 2 times positive sine square theta, that will be negative 2 sine square theta. And this is a like term to that one. I have 6 minus 2, that will be 4. That will be a 4 sine square theta, and then there's going to be 7 sine theta cos theta minus 2, and then I will have cosine square theta, which is similar to that, by the way, but it took me long to get there. All right, so now that we're here, we can go ahead and simply factorize this thing, and we will create a 0. So the 4 and the 2 will multiply to give us an 8, and we just need to put 1 to get the difference of a 7. So I'm going to have 4 sine theta, and then the times sine theta, and then 2 will be there, because the 4 and the 2 need to multiply. Remember, they are the outer terms. And then the factors of 2, because the 4 is 4 and 1. Yeah, 4 and 1. The 2 is also a 2 and 1. Those are the ones that are going to work for me. So if I subtract the 1 from the 8, I'm going to get a 7. But I need to make sure that the 8 is the one that was negative, and the 1 is the one that's positive, to get a negative 7. We just simply treat those signs like that. So f 4 sine theta equals 1, or sine theta equals, that's going to be a 2. All right, so the 2 here won't be part of our solution. We don't have to waste our time with that. So I'm done, except I'm making a mistake here, because I need to make sure that these numbers are not alone, they have the cosine. All right, let me just make sure that I fixed that. It kind of skipped my attention. So this is not 1 and 2 only, is 1 times the cosine, which is going to be cosine theta, and then this is 2 times cosine theta. All right, because it's a perfect trinomial. This number is not a constant here, and I have that in the middle term. All right, so now that that's being done, this is going to be 4 sine theta equals a negative cosine theta, and then this is going to be sine theta equals a positive 2 cosine theta. And then you know what to do: divide by cosine theta, divide by cosine theta, and this is going to give us a 4 tangent theta equals negative 1. And then again we'll do the same thing here, like that. This is going to be tangent theta equals that, and that will cancel. We simply have a 1, and we'll times that by 2. So here we just simply have to divide by 4, and then we'll tangent theta equals negative 1 over 4. Now here we don't have to worry about a. Whenever tangent theta is involved, the a should be the element of real numbers, so I'm fine with that. I'm just going to go ahead and work. I do not have to caution anything whether that number belongs within the interval of negative 1 and 1. So what I'm going to do is simply to say what is that going to equals. Now I have to write tangent second function 1 over 4, and then I'm going to punch a calculator. So that's going to be shift tangent negative 1 over 4, negative 1 over 4, which is going to be, that's going to be a negative 14.06. It's a negative 14.06, rather a negative angle. We haven't come across the negative angle as yet, but it is what it is. Okay, so that's going to be multiplied by 180 times k, where again k is an element of integers. All right, so if we do add 180 times k, you will be able to get a more accurate, whenever you substitute k for any number, you get a more accurate angle or a positive angle. For the other one, however, is gonna be 2. All right, so I'm gonna have second function tangent 2, not a 1 at 2, which is 63,43. So this one, the theta is gonna be 63,43 degrees plus 180 times k, where k is an element of integers, and then you're done.